Hey guys, and welcome back. In the last video we talked about SDLC and STLC, so the software development and testing life cycles. And now that you have a bit more of a background in the software testing processes and you understand how they fit in the overall software development process better, we can start talking about the software testing techniques. And this is an important topic because not only this will help you in the early stages of your career before you have developed a sort of an intuition, like a tester's intuition, but it is also a popular topic for interviewers to be asking you questions on your first round of interview as a beginner tester. So stay tuned and let's get right into it. Okay, so there are generally three categories of software testing techniques. There is white box testing, black box testing, and experience-based testing. We will start with white box testing, even though it's the harder one of the three, and we can move it out of the way a bit easier, given the fact that you don't necessarily need to have white box testing skills in order for you to apply for a job as a beginner tester. Anyways, we can cover white box testing quickly, just so that you have context on what that is and how it is different from the other techniques. So white box testing is basically an approach where it is assumed that the software that you're testing is like a box, more like a transparent box than a white box, which is accepting inputs and producing outputs of some sort, but you know how it is processing the inputs in order to produce the outputs. In other words, you have access and visibility into the code behind the application, and you basically need to test the code as well to ensure that it functions and performs as it should. Now, as you might have guessed, like for this, you would need to learn a programming language, you would need to learn a couple of tools more. So it's a bit complex, but luckily for you, as I mentioned, you don't need this in the early stages of your career at the very least. There is a variety of positions out there that require software testers without any white box testing skills. This is also why our course will mainly be focused around black box testing and experience-based testing and a mix of those. So in the second part of our video, we will go through the black box testing and the experience-based testing techniques in more detail. So black box testing is a technique where, again, you're dealing with a box, but this time the box is black and it's not transparent. In other words, you don't see what's going on inside and you don't care. So there are some inputs that come into the box and they're processed and they get out of it in the form of some sort of outputs, but you don't know or you don't care what's going on inside, basically. So you would have to structure your testing somehow, because let's say for that box, the specific box, you have a bunch of requirements defined on the type of inputs that it is expected to be able to accept, and how it should, not how it should, but like what kind of outputs it should yield later on. There might be tons of different scenarios, so you need some sort of an approach or a structure. And under black box testing, there are 5 techniques which will help you in case you're lost or you haven't developed like an intuition yet. It will help you to structure your testing. So in terms of preparing for your testing, when you're just creating your test cases or when you're actually executing them. So the 5 techniques are equivalence partitioning, boundary value analysis, decision table testing, state transition testing, and use case testing. And all of these on their own, they don't you can't just use one of these techniques and test the whole application as a whole. It's always going to be a combination of all of these, or sometimes you won't be using some of them at all. Like, I mean, there are some techniques under black box testing that I haven't used much, almost like never, I would say. But then it's always a mix. So you use that, and also even the experience-based testing techniques, you would always need to combine them. It's never just like, okay, like now I'm at work, this is a piece of software I need to test, and I'll start with just using the boundary value analysis and go through and test. It's always a combo. Let's go through them one by one, and then we'll draw conclusions on what's the best way to combine all of this later on at the end of the video. Equivalence partitioning is the first one we'll cover, and that's basically a technique where you're splitting the set of data that you have, the type of inputs that you want to provide to your software, into different partitions or like parts, sets of data basically. So let's say you have a registration page where you have a field which is expected to, which is supposed to be accepting values from 1 to 100. So you say only values from 1 to 100 should be valid, anything else should be wrong, and then the system should prompt with some sort of an error message. So how you would approach testing this field using the equivalence partitioning technique is you would split the possible data that you can provide to it into a couple of partitions. So you will have your valid partition, which will be from the numbers from 1 to 100, obviously, which if entered should always behave the same way, meaning like the system should be happy, basically it should accept those values. And you would have values which are above 100, so something more than 100, like 110, 115, which will be the first set of your invalid values. And then you will have values, say, below 0, which would also be another set of invalid values. So you would want to test these values in order to ensure that you have enough coverage for this field, that in case of a wrong input is provided, the system doesn't misbehave, or it behaves as it should, provides the right error, so on and so forth. Equivalence partitioning method is usually used with the boundary value analysis technique. So basically they're most of the time combined if you use them. And boundary value analysis is when you test the boundary values of each of those partitions and a bit more. So let's say you have these 3 partitions again. You have 1 to 100, 101 and more, and basically 0 and less. So you would basically pick up the edge values. So you will pick up the in case of your valid partition, you will pick up the number 1, the number 100, and you will test those in order to ensure that the edge values are correct, and you will make an assumption that everything that's in between should also be working. Because imagine if your field would be accepting values from 1 to a million or a billion, you won't be able to test it a billion times, like with billion values provided separately, right? So you need to make some assumptions. But to improve that, you would basically take not only the edge values, you would take also the just directly adjacent values to those. So you will take the 1 and you will take the 100, but you will also test the 2 because it's right next to 1. You will also test the 99 because it's also right next to 100, and then you would want to pick something in the middle, like the number 50, for example, and test that as well. It will just give you a bit more confidence that your expectation is going to be valid, most probably. And then you would do the same for the edge values of the or the boundary values of your invalid partition. So you will take the 101 as the first invalid value, and then you will take, let's say, 0 or -1, whatever, and then you try to give it as an input and ensure that the software behaves again as expected, meaning like it prompts you with some sort of an error saying that it's invalid, or it just doesn't accept the value, for example. Right, hope these two are clear, and the next one that we'll go through are the decision table testing, the state transition testing, and then the use case testing, so stay tuned. Okay, so decision table testing is the next one, and it is a technique that is used when you're dealing with particularly complex pieces of logic inside your software application. And let's explore this on an example to make it like as little confusing for you as possible. Basically, assume that, for example, you have a login page which has a login field and a password field and a login button, and you need to test different types of scenarios and the different types of linked action in case of one or the other of the scenarios is right or wrong. So say you input a correct login but an incorrect password, what would you expect the software to do? Or you do the other way around, you provide an incorrect login but a correct password, or say you haven't provided one of the inputs to one of the fields, or I don't know, your user doesn't exist, for example, like you haven't registered before. So all of these are kind of conditions, right? And types of actions that the software could perform would be like it would log you in and take you to your home page if your credentials are correct. It would basically throw you an error message saying that your something is wrong, like your login field is entered incorrectly, or your password field is entered incorrectly, and so on and so forth. So you would basically create a table where the rows would be first your conditions. So you will specify your conditions as like correct login provided, correct password provided, incorrect password provided, so on and so forth. And then you will list the actions that the software should perform, like login to the home page of the user, throw an error message, so on and so forth. And then as columns, you would have your test cases, so different variations. So what happens when your correct login is provided is a yes, and correct password is provided is a no. So the corresponding action would have to be the system throws you some sort of an error, and then you can define it specifically if you want as an action. Like, this is one of the techniques that I haven't used much, because in many cases, like, there is a combination of all of the other types of techniques that can help you cover this, but it can become helpful when you're really dealing with a super complex piece of logic inside the software, where you don't have any other way of specifying test cases or writing test cases in a structured way better than this, where you really need to test all of these different types of combinations. I'll leave a link in the description in case you want to explore this even further. There's like some nice videos that you can watch with some more examples of some complex pieces of logic, but you get the idea already. Then you have the state transition testing, which is a technique which is used to evaluate different states of the application and how they transition between them. Again, if we explore the example of the login page, let's say you have a correct login provided, and you provide an incorrect password, so it will throw you an error message. It will show you a new page or a pop-up which says basically, yeah, your password is incorrect or something. And then say you have provided a correct login credential and a correct password, and it will log you to your home page. But what if you have provided your password wrong for 3 times, and there is a logic which is required for the software to implement or to execute, that is to lock your account down, for example, and tell you to contact the administrator or someone else. And so all of these kind of scenarios can happen. So these are transitions from one state to the other. So let's say if you have provided your login correct, but your password incorrect, the system would log your first attempt. And for now, it will basically evaluate, like, am I within the limit of the incorrect, the number of incorrect input passwords that I've received? If I am, then I am gonna give another attempt to the user. If I am not, then I'm gonna basically lock his account down. So you would basically, when preparing your test cases for testing this type of scenarios, you would create a diagram where it shows what happens in each of the cases. So say, correct login, incorrect password, case number 1, the transition should be to this stage, or to this page, or to this pop-up, whatever, or to this state rather, and then so on and so forth. And then at the end you would have, for example, a scenario where, yeah, we've reached the limit, and then the transition should take me to the state where my account is locked, basically. And this is how this technique is used. You can get like fancy with it. You can explore it on some more examples. You can think of some of on your own, and you can even post them in the comments. And I'll also leave a link in the description for you to explore this a bit more as well. All right, and the last technique that we have is the use case testing under black box testing category. And use case testing is a technique which is used to evaluate the system, to test the system from the standpoint of different actual user cases defined in the business requirements or the technical requirements of your project or your product, and these are predefined requirements which you go through, and you basically link your test cases to them as such. So this is the technique that I use the most, or maybe it is one of the more used ones out of the black box test techniques, and it's linked with the rest and it's combined, but this is particularly popular. So you would basically have, for example, your software is going to be used by a certain type of a user or different types of users, or even a machine. You would define the role of the user. So whatever, like this type of user is using the software and it's supposed to be producing this sort of an outcome. Like, for example, when an admin user tries to reset a locked account, it should be allowed. This is just a primitive example. Or when a non-admin user, a regular user, tries to do something, then it's not allowed, so on and so forth. So basically, like, the list of requirements that you have would be guiding your testing, and you would be writing your test cases off the back of those. That's why it's called like use case testing, because your structure is based on different types of use cases of the software. Right, this wraps up the black box testing techniques summary. Let's quickly go through the experience-based testing techniques and then draw some conclusions in the end. Okay, lastly, we have experience-based testing, and this is the easier one to understand from them all because it basically requires you just to use your past experience as a tester or knowing the product and use your intuition as well to try to understand where issues can be in the software. And the two techniques that are under it that we'll cover briefly are the error guessing technique and the exploratory testing technique. The error guessing technique, as the word suggests, is pretty simple. You basically use your knowledge of the platform or similar types of products, and you basically try to guess where most likely issues will occur because, for example, you've seen them occur in past in similar areas or in similar scenarios, or because you just know that there have been a change recently in that area and likely there will be some defects coming out of that area. In terms of the structure of this, like this is like a less structured approach, and as I mentioned earlier, this is almost always combined with all of the other more formal testing techniques, or throughout the software testing lifecycle you will have a phase when you will do this separately just to kind of ensure that another layer of testing is covered. Then you have the exploratory testing, and that is basically when you're just using the software, like, you know, you go on a session of using the software as an end user would, and then you try to find issues spontaneously. So you test, then you record what you have tested, what areas you have tested, and what issues you have found. And it's basically, as the word suggests, you're just exploring the system. You just go ad hoc, clicking around, trying to see how different features work, and based on that, if any issues come out of it or not. And again, this one as well is a less formal technique, but which is always very beneficial because this helps find issues which the more structured types of testing that we covered before have missed, and it's just targeted at specific types of issues, usually the types of issues that the end users would find accidentally. Right, so this covers it pretty much, guys. We went through all of the testing techniques today. We covered them all, but an important conclusion that I want us all to arrive is basically the fact that you can't use just a single testing technique to test a whole software application. It's always a combination, and what you should always keep in mind is the fact that the end user is always right. Whatever technique you use, however you try to create your test cases and then execute them, you should always keep the end user in mind. And for whatever reason, if you're ever lost with whatever you're doing using each of these techniques, or you're kind of getting confused, try to think as an end user, and it will help you. Try to tell to yourself, what would the end user expect of this specific piece of functionality? How would he want me to kind of ensure that this is of sufficient quality, that this piece of feature is of sufficient quality? How would he use it? How would he misuse it? And then test it that way. And it will guide you all of the, even the structured test preparation based on those structured testing techniques. Right, guys, thanks a lot for watching this video, and thanks a lot for sharing the word. I've seen some people, some new subscribers joining the channel, and if you like these videos, don't forget to subscribe to the channel and share the word out, like share the video or hit the like button. If you liked it, leave some comments under that. In the upcoming videos, we're going to be going through some more practical examples, and we will talk. First, we need to go through a bit more of the theory in 1 or 2 videos, just so that you have a solid foundation, and then we will start exploring all of this on actual real-life examples on real applications. Cheers, guys, and I'll see you next week.